Hi everyone. Good evening. So welcome to my experiment about machine learning. So this will be a live stream and I will be coding most of the time. What you see here is one of the 3 slides I think I have tonight. So we're going to talk about Azure Machine Learning Service and what it means for people to set up a machine learning project properly in the cloud, and how to do a bit of MLOps in production. So let's get started. So for those who don't know me, most of my colleagues will know me actually, I think. I'm a technology advocate at InfoSupport, so my daily job is to help people get started with things like machine learning, data lakes, databases, but also a lot of .NET stuff, ASP.NET Core, microservices, that sort of stuff. That's what I do daily. Apart from that, I do a lot of AI stuff, as you can imagine from the fact that I have a Microsoft AI MVP award for the 2nd time in a row. Before that, I was in a Visual Studio category, doing Java actually, not so much .NET back then. So I do run a community, the Global AI Community, which is a free organization that organizes meetups around the world. You can learn about AI in various stages, so we do have a lot of data science stuff. We do have things like cognitive services, how to use that. It's mostly Microsoft oriented, but we do have some external parties doing other things as well. If you're interested, I will share a link at the end of this session. 8 April, we'll be streaming live for 30 hours straight, teaching you all about AI and machine learning. I've got 30 speakers lined up at the moment, and they're going to talk about cognitive services, reinforcement learning, video indexing, search. There's a lot of stuff in there. So that's my shameless plug on that topic. So if you'd like to get in touch with me, I'm on Twitch. I've got a Twitter account. I've got an email address and a LinkedIn profile that you can look up. So as I mentioned, we're going to talk about Azure Machine Learning Service. So for those of you who have done machine learning before, one of the hardest topics in machine learning is actually trying to version more than just your code. That's actually the hardest part, I think. And Azure Machine Learning Service helps you set up proper versioning of data and models in addition to code, but it also helps you set up models in production, so deploying them to Azure Kubernetes Service. Is my mic muted? No, it's not, right? No, it's not. So that's a good question. So we're going to talk about this whole product, Azure Machine Learning Service, and we're going to walk you through setting up a machine learning project properly, and then training a model on a training cluster, which is the middle section of this slide actually. It's all about training models on clusters using graphics cards, that sort of stuff. And then finally we'll talk about using the model registry to register a model, and finally we're going to deploy it to production. So this session is not so much about teaching you how to do machine learning, I have to be honest, but you'll see me fumble and try stuff out based on the dataset that I have, and see if I can get a machine learning project running on Azure Machine Learning Service and get it to production. So the case that we're going to work on today is a customer churn model. I've used this model before, so people that have seen my courses on machine learning, they know about this dataset. I use it quite frequently. Basically, the idea is that we're going to predict when a customer is about to leave for your company. So in this case, my dataset is from a telecom company, and people are going to leave this company because either the price is not right, or quality is bad, or that sort of stuff. And we're going to try to predict when that happens. So the marketing department can call them or ask them for any feedback or that sort of stuff. That's the scenario that we're going to work on today. So let's let's dive into why you would actually use Azure Machine Learning Service. So when we do machine learning, something strange happens actually when I see people work on machine learning projects. So a normal software engineer actually follows a lot of best practices these days. So we have source control for our code, we have a build pipeline to build our software and possibly deploy it to production. We've got tests, we even can do something like mutation testing. It's all there. Basically, if you ask a average info support developer, I think that most of them will know how to set up tests and deploy to production automatically, either by using Jenkins and GitLab or Azure DevOps or anything of that nature. But when I ask the same question to a data scientist, something weird happens. The data scientist says, deploying a model to production, what's that? I will grab my model, zip it up, and email it to you. I don't know anything about source control. I don't know anything about doing something like Azure DevOps or Jenkins or anything of that nature. They somehow live in the 90s. That's my feeling about it. And that bothers me as a software engineer. I mean, it's kind of ridiculous that that people would do that in 2020. So, William asks, can someone please pass me the attendance list? Gert-Jan is not here, so don't worry about it. It will be fine. So grab your cup of coffee and relax. I'll make sure that he knows you've been here. Maybe Gert-Jan is here as well. I don't know. So that's one of the things that bothers me, sharing models through email and possibly datasets as well. So I have a lot of students working on projects at InfoSupport, either for their master thesis or a bachelor thesis. And one of the things that I see them doing is store their data on Google Drive or in Dropbox or that sort of solutions. That's also pretty bad. Sometimes I ask them, so how do you know what dataset you use to train this model? And they will answer me, how is that important? Well, the problem that we have in machine learning is actually that reproducing a model after it's trained is kind of hard. So going back to the basics of machine learning here is that basically what we do in machine learning is we grab a data set. From this data set we pull out samples that we use to train. And one column in this sample, one feature if you will, is the output that we're going to train on, and the rest of the features in the data set is actually used as input to train on. And we take this data and we pull it through a machine learning algorithm, and out comes a model. But this algorithm uses random numbers to get started, so that's the first thing that causes problems when you train again. The second time you train the model, that random number is different. Also, if you don't save the dataset that you've used to train the model, that will also cause problems, because the next time you will use a different dataset and that will produce a different model logically. And that's a problem. So basically what you want to do to maximize your reproducibility of a machine learning model is to store the dataset that you've used, all the settings that you've used, and the code that you've used. So it's not a normal software engineering problem. In software engineering, we basically store the code and that's it, and we build that into a asset that we deploy to production. When you do machine learning, you have to do a lot more. You have to grab the code, you have to build that, then you have to train a model using a predefined dataset that I've versioned somehow, and then I have to store the model and version that as well to make sure that next time when I get a question about the model, its performance or any other problems, that we can answer those. So Azure Machine Learning Service helps you in this department, and it's a rather important step to do when you want to run machine learning models in production. Finally, when we look at machine learning, there's another problem. So training models in machine learning is not that bad if you have a small data set and a linear model or something like a decision tree. Let's say the basic machine learning models. You can do that on your laptop or you can do that on a build server, that's fine. But as soon as you start using deep learning or reinforcement learning, then you need a dedicated training environment, separate from your build server. Your build server typically doesn't have a graphics card that you will need to do deep learning or reinforcement learning. The goal for us when training a model is to maximize CPU and graphics card usage on your machine. Every time you train a model, it basically runs a 10,000, 20,000, 100,000 passes over your dataset in search of the right settings for the model. That's what's happening during training. If you think about that, the problem here is that takes a lot of CPU power. It takes a long time to train a model. And if I do that on a build server, I can't do anything else. And another problem is a build server is not as fast as a machine learning server that you can use. So Azure Machine Learning Service helps you here by providing you with a dedicated training environment. So that's the reason why we have Azure Machine Learning Service. It helps you reproduce machine learning models by storing metrics and log data and input. It helps you by storing your dataset and versioning it, and then also versioning your models and even deploying your models to production if you want to. And finally, it helps you with dedicated training environments and profiling and all that stuff. So, given that we want all these three things, let me show you around. So the rest of the session is basically me live coding a machine learning project on customer churn. That's what we're going to do. And first I'll show you how I set up my machine learning projects that I do for my work. I've got a template that you can use, but I will talk you through it, how that actually works and what I do in preparation of a new project. Of course, I've got some stuff prepared, but I will show you nonetheless. Then when we've set up our project, we're going to train a model in the cloud on a training cluster. I will show you how to set up a machine learning workspace in the cloud. I will show you how to set up a training cluster. And I will show you all the neat stuff that Azure Machine Learning Service is actually doing for you to make this all possible. And finally, we'll take a look at deploying the models to production and maybe, I'm not sure. We'll also take a look at explaining models, but it depends on how much time I have. So, if you have any questions, please shout out in the chat. Let me know. I will keep an eye out on the chat. You see me pointing in this direction. That's where my second screen is, where I see myself talking and I see you people all chatting away. Edwin is watching the MVP Summit. In the meantime, no eating in the seminar room. Okay. Yeah. Cool. Kickbox Live. Manon. Kickbox Live? That's cool. I didn't know that existed. So we have a yoga session planned for later tonight, I think. But Edwin knows. Okay. Let me close this one down. We don't need to see my Slack channel. Let's get started. So, first things first, we have to set up a machine learning project. What you see here on my screen is my Windows terminal with a project pre-generated. So normally what I would do is this. I would first say conda create -n my environment, and I want to use Python 3.7. So basically what this does, I'm using Anaconda, which is a tool. So most data scientists and machine learning engineers use Python, which is a programming language that's dynamically typed, and it's really easy to learn actually. You can learn it in 20 minutes, I believe, which is really fast for a programming language. So Python comes in two tastes, if you want. There's the regular Python, which doesn't include anything but the basic stuff to install packages and to run Python scripts. And then there's Anaconda, which is a scientific distribution of Python. What does that mean? This version of Anaconda includes things like NumPy, which is a numeric package. You can do vector math, you can do matrix math, you can do all sorts of cool things in statistics, random numbers, that's all included. This also includes Pandas, which is a library that allows you to process data in the shape of tables. So I can load up CSV files, Excel files, databases, Hadoop file systems, that sort of stuff, and manipulate that. I can show you that in a minute, what that looks like. And it also includes a machine learning library. Yeah, that's a good question, Olaf. I can increase the font size of my terminal, certainly. Give me a second to do that, actually. It's all live, so you're going to see my settings in here. So I can say font size 16 is about right. Olaf, is that better? I can imagine, yeah, this is my screen and it's all in full HD, so we might have problems further down the line. Cool, cool, cool. Thanks. That was it. So I'm running Anaconda on my machine for the simple reason that on Windows this makes it a lot easier to do machine learning. If, however, you're running on Linux, you can also install the regular Python and then install the NumPy and the Pandas and all the other stuff on top of that yourself. Why is that difference? So NumPy requires CPU optimized native code to do the math thingy that it's doing. And on Linux, this package is free. On Windows, however, you have to go through several hoops, going to Intel, asking them, pretty please, can I download your package? And Intel says, sure, you can, but you have to leave your name and number, which is, I think, kind of ridiculous if you think about it. So on Windows, that's kind of a nightmare. I'm not even going to show you how to do that. Upgrade Python to a scientific version. Anaconda is the way to go, actually. So download this, install it, make sure that you add it to your path, and then you're good to go. So you get in your command line, you get a tool called Conda, which allows you to manage Anaconda installation. Conda allows you to create virtual environments. So normally when I run Python on my machine, I can only install one version of each package ever. So if I've got Pandas 0.8, it will be there. When I install version 1.0 because another project uses that, I'm basically screwed. Because then I have 1.0 and I can't use the old version anymore in my other project. So the virtual environments solve that problem. They allow you to install multiple versions of Python actually, so I can run Python 3.5, 3.1 and 3.7 on my same computer as long as I switch between the environments. So Conda Create helps me set up my environment. I give it a name, -n, I give it something descriptive, as you can imagine, and then I will specify which Python version to install. And another pro tip, add pip as well. Pip is a Python package manager which allows you to install additional libraries and tools that you might need further down the road. So I already have one. So what I can do, once you've created the environment, is conda activate Azure ML customer Churn. And I will activate my environment, and I can see that because I have this indicator on my command line prompt. If you're interested in this stuff, by the way, there's a tool called Oh My Posh. So I'm using PowerShell as my go-to shell, and it has an add-on, Oh My PowerShell. And Oh My PowerShell allows you to customize your prompt and include this sort of information. I haven't done anything special. It's included in my in the base installation. So for me, this is important because now I can see that I'm working in the right environment. So once I'm in my environment, I can start to set up my project. I'm actually using a tool for that. It's called Cookie Cutter. I'll show you. Cookie Cutter. For those of you who've done Java development or .NET development, so in Java you have Maven as a build tool, and in Maven you've got archetypes, basically project templates. In Marco asked, I have a cookie cutter too, but I've been using it wrong. How have you been using that thing? This is the only cookie cutter that I know. Well, no, not true. There's two versions. There's the metal thingy that you can use to create sand cookies, and there's this. Think of it as the metal thing, but then for Python. Cutting snake cookies, I would say. So, Cookie Cutter is an open source package for Python, and it's basically a project template library. So in Visual Studio, you've got project templates included, or you could do .NET New. In Java, you've got Maven, and you can say, I think it's Maven Create or something. People doing Java development, anybody know? No idea, okay. So, yeah, this is for Python. So what I can do with this, you can actually install it through this. Cookie Cutter. A Cookie Cutter shark. Maven archetype generate. That's the command for Java, yeah. So in my case, I've got Cookie Cutter installed. So when you run pip install, pip install Cookie Cutter, it downloads the Cookie Cutter package and it installs it, and after that you've got a command which is called Cookie Cutter, and it says, hey, you're not adding any template. Thank you very much. Please do that. Well, let's do that. So what I have actually is a project called, I've got a lot of open source projects, by the way. So I've got a project which is called Azure ML Cookie Cutter. So I created my own template actually for this. Microsoft doesn't provide any template for using Azure Machine Learning Service from Python in any way. You have to go to the Microsoft documentation and figure it out yourself, basically. Which is sad if you ask me, because it's a lot of work. And I personally feel that it could be a lot easier, so I created a project template instead. So what I can do now is say, hey, I've got a Cookie Cutter template, which is hosted on my GitHub. So when I run this, it will ask me, you've downloaded this stuff before, do you want to delete it? Yeah, that's fine. So now it will ask me, ignore this stuff. I'm running a beta version, so it might be broken. It asked me for a project directory, so I can say customer churn 2. Project name, customer churn. And then a package name, customer churn. And what it has done now, it has created a directory which is called customer churn 2. And let's take a look at what that looks like. So customer churn 2. I can open that up in my editor, which I will zoom in for you. So this is my project now. It generated a README file which describes how to use this project actually. Some tips and tricks on how to use data and how to do other stuff. It generated a environment file for you, so I created my environment manually using Conda. But that's not the only way to do it. If you work in a team, it's very nice if you could share your machine learning environment with somebody else. So what you can do is you can describe the environment in a YAML file, specifying a Python version, which I'm going to upgrade to 3.7, with a number of packages, either coming from Anaconda itself or using the Python package manager. These top ones are important. This is actually the default installation of the Azure Machine Learning Service SDK on your machine. This one is some additional packages that you might use for data processing. Good question, Edwin. Is there a Docker image with all this tooling already in it? Yes and no. So if you're running on the Azure notebooks, it's included. It works out of the box. I could create a Docker image. Yeah, I can include a Docker file with this one, if you absolutely want me to. It shouldn't be too hard, actually. That's a good one. Yeah. So if you're using Azure Notebooks, everything is installed for you, but I'm not using that for a good reason, actually. I feel, personally, that notebooks, and Python notebooks, I will show you in a minute what that actually is, are evil. Very, very evil. So, yeah, I'll get back to that. So, this is my environment setup. I've got a bunch of ignore files that I'm going to use, and some build tasks. These build tasks will go over these once we are going to start developing the project properly. Then there's a folder that stores your datasets if you're working locally. We're going to upload them into the cloud, but this is where you start actually. And then there's a folder customer churn, which I specified, which contains code for training a model and making predictions using a model. I need a soundboard. So somebody is asking, you need a soundboard. Do I? I've got a Stream Deck. Does that count? And no, I don't play Fortnite ever. I play World of Warcraft from time to time, but not too often anymore. For evil laughs, yeah. Oh, that's a good one. I've got some room left on my Stream Deck, so I can probably add that later. But not in this stream. Cool. So this is my basic project layout. Going back to what I have set up already. So let's grab that customer Azure ML customer churn code. So I did some prep work this afternoon. I figured that I wanted to stream tonight, this morning. Actually earlier this week, but this morning it was finalized, and this afternoon from 5 till 6 p.m. I worked on the demo itself. So expect some breakages, to be honest. So let's start. Let's start at the beginning of my project. So what I have here is a raw dataset. This is my customer churn dataset. It's a lot of stuff. There's, I think, 7,044 rows included in my dataset, which is a lot. Imagine trying to make a piece of code that tries to predict when somebody is about to leave your company for something else. That's impossible for 7,000 different conditions, combinations, and all that stuff. Some might overlap, but... So let's see how we can do this using machine learning. So let's first start at the beginning. When I start a machine learning project and I get a dataset from a customer, typically what I do is start to profile that dataset. I use pandas for this because I'm processing data, and I'm using another tool, pandas profiling. So this is a Python notebook, by the way. I do all of my exploration, all the stuff that's a sort of a throwaway piece of code, in notebooks. Python can be run as scripts and as notebooks. So scripts run in order. You start them on the command line, so I can do this. I can use Python and then some script file, and that will run the script file. Python notebooks are different because they allow you to mix documentation, such as Markdown, with code. So this is kind of cool. Yes, that's a VS Code extension. So VS Code is this code editor that allows you to edit a bunch of languages. I've got a lot of stuff installed, but this extension that I'm using is Python extension. It's this one from Microsoft. Who knew? Microsoft not doing C# only, people. They are doing a lot more. They actually... Where is it? No, that's not the right one. They actually have a Java extension as well. It's pretty cool. It got me excited for Java again. Let's put it that way. So this Python extension allows you to run Jupyter notebooks, so the Python notebooks, inside Visual Studio Code. Normally you would have to run them in your browser, which sucks. Which is even worse than using notebooks itself. It also includes debugging, so I can press F5 in my scripts and you can set breakpoints and you can debug them. It's got IntelliSense, which is kind of amazing in Python. Remember that Python is a dynamic language, so it doesn't have the types in the sense that you would have expected from Java or C#. You will only know the type at runtime. I don't know how they do this, but they don't have to run your script to actually figure out the type. To me, that's magic. There's a trick to it, I think. But they also have code formatting from refactoring unit testing. They also do that. So it's pretty cool. A good thing to know is that right now, because I've started from my directory from my terminal with the Azure ML customer churn environment activated, it will also activate it inside Visual Studio Code. But you can switch if you want to. So you can also run the virtual environments in here. Consequently, the notebook also runs in the same environment, so it's all connected. And in your notebook you can document in code. So that's the nice thing about notebooks. You can combine documentation and graphs and images with pieces of code. And those pieces of code can also produce graphs. Probably Roslyn. It is a good question, Edwin, but I don't think they are using Roslyn underneath. I would be surprised if they were, at least. I don't know. I've spoken to the team once and they wouldn't tell me. So yeah, so what I could do is for each of these cells I can run them, and they will get queued inside Python, and out comes the output. So this one imports my pandas package, just like you would in Java or .NET, a using statement if you will. This one imports my profile report class from this pandas profiling package. Then what I do is I ask pandas to read my CSV file from this raw directory that I have over here, which contains the CSV file. And what I've done, when I specify nothing, it will just read the file and that's it. And I will try to guess all sorts of settings, which might end up working, it might not work, you never know upfront. In this case, I know for a fact that there's one column, total charges, you can see it over here, which contains empty values, but those are encoded as spaces, actually. This is the one thing that I encounter a lot in production, actually. When I go up to a customer and I ask them about data quality, they say, sure, it's fine, it's no problem. You can use that for machine learning. I don't know why you're creating datasets. Well, there's a very good reason why I want to create a version dataset. Because they mess up the database all the time. I get a lot of comments. Our CRM system is so crappy we can't migrate it to the new solution. Our configuration database is so massively broken that we'll have to manually convert it to a new solution. Our invoice database, yeah, it's mostly correct because we have to, because the tax office wants us to keep it up to date. But actually there's a lot of broken invoices in there. That happens all the time. So in this case, I've got a space for a not available. Who knew? So by setting the NA value setting, I can specify that these spaces need to be treated as not available. So a data frame in this case contains rows and columns, so it's column oriented. I can do all sorts of fun stuff with that. But one of the important things that I do when I start is that I grab my data frame and I ask for the info method. The info method returns you a lot of statistics about a dataset. So I know that there's actually 7,043 entries. And out of these entries, it has deduced that these are the columns. And the first column tells you the name of the column. The second one tells you the number of non-null entries. But this is important. Scanning this list, I can see that most of the data is actually pretty cool, but total charges is broken. There's a couple of missing entries in here. Finally, there's a type for each column. So object is basically a string or anything that can't be encoded as a number. So in this case, phone service is a string, this is a string, and this as well, this as well. Most of it is categorical data actually, like I will show you. Then there's two columns, monthly charges and total charges, which are floating point numbers. So these contain money values. So now I know that my data quality is basically broken at this point, because if I want to do machine learning, I have to make sure that for each of the columns that I want to use as input, which is all of these that I've selected here, need to have values in them. So this is not going to fly, but I can fix that. Then there's the final column, Churn. This is the one that we're going to use for predicting. This contains either yes or no. So we're going to make a model that says, based on these inputs, the customer is going to leave or he's going to stay. So going beyond that, this is very basic. This only tells me I've got a few missing rows. That's a good question. So is it able to guess regional settings correctly? Comma as a 1000 separator. No, it doesn't. No, it uses a standard format, so you can change all that. So you can actually, if you go into documentation, they will help you get started and they will explain how to actually do all the stuff that you want to do. So I can say read CSV. So there's a bunch of settings. So you can specify how to format certain things. I can say true values, false values. I can say parse dates. I can fix that, date format. But mostly it will do the American style formatting. So if you have a number in there that has a comma instead of a dot, it will not parse it as a number. But you can fix that. So basically what you need to do is a lot of this stuff. Customer churn, drop NA, for example. This will get rid of the missing rows. And what you will see me do here is perform an operation on the data frame and then store it again in a variable. So data frames and pandas are immutable. You can say replace in place and all that stuff, but I wouldn't touch it. But for the most part, if you, for example, drop missing rows, it will create a new copy of your data frame for that, excluding the rows that you want to remove. Going back to your question about formatting of values, so I can manipulate the data inside the data frame using operations. So I can say customer churn monthly charges. So I can select the monthly charges column, and I can say apply, and I can use a lambda, which takes the value that was stored in the column, and I can do all sorts of weird things with that. I can, for example, replace a comma for a dot. I can remove the comma if I've got an extra one. I can lowercase, uppercase, all that stuff that's working. So this is what you will see your average data engineers doing during the day. 80% of the work is actually this stuff. So that's quite a lot. But we're not going to do that in a notebook, because a notebook doesn't have a fixed order. I mentioned before, notebooks are pretty evil. Because, yeah, I can change the order of these cells. I can say, hey, move it down. So now, I'm actually asking for info first and then reading the file. That's kind of strange. You don't want to do that. But because now I have to remember, oh, I need to read first, then go to the previous cell. I don't know why, but it's there. And I have to run that. Also, in addition to this ordering problem, there's a second problem. When I save this file on disk, it's stored as a JSON file. So, when you have two people working on this file, and they change something, the JSON structure that's underneath there will change. And it's a quite complicated structure. So, merging this file in Git is not going to fly. It's breaking badly. Also, when I'm trying to run this notebook on my build server, it doesn't want to. You can't run notebooks as if they were Python scripts. So that's why I think this is pretty evil. And I only use it as sort of my scratchbook, if you will. So now that we know that what the data looks like, I can actually try to fix my data setup. So let's go over that, how that works. And I'm going to use Azure Machine Learning Service to store my data model. So let's stop for now in this project structure. You know what it looks like. That there's build tasks, that you can add notebooks, you can have data, and you can have Python code. Let's go over to Azure Machine Learning Service. So how do you set one up? What I can do actually is, when I search for Azure Machine Learning, there's an option to create a new machine learning environment. So I can say add, and it will take me to the wizard to set one up. And there's a couple of options you should know about. So there's the typical stuff, resource groups. You have to have all your Azure resources in a resource group. Your subscription is important, a region, and then finally an edition. There's a basic edition of Azure Machine Learning Service and an enterprise edition. The basic edition is cheap, but it also misses a lot of cool features, I would say. It does work. If you're only using Python, this is the way to go, I think. But if you want more, then enterprise is the way to go. So you can specify all this, you can click create, and it will create the environment for you. Let's see what it looks like if I go into the Azure portal and I look at the customer churn workspace that I've created. This is actually the normal view that you would see for app services, for functions, for Cosmos DB, for any service that you run in Azure. This is kind of basic, but there's something really cool. There's Azure Machine Learning Studio that you can use instead of the Azure Machine Learning portal. Because in the portal you can see the experiments. These are used for training my models. Build pipelines, training clusters, model registry. This is where I keep my models and version them. Docker images for production. Deployments, either to AKS or Azure Container instances, and other properties. But this is pretty old. I wouldn't use this. So instead I want to go to the Azure Machine Learning Studio. So the Azure Machine Learning Studio, as you can see, is still in preview. It's a very new tool. It will break badly sometimes. It's being deployed every month, I think. So I keep updating my stuff every month because it breaks. But in there, I can find one of the important things for my project is datasets. And in here, I've got registered datasets, and each dataset has a name and a version. And it's a tabular dataset. So you can not only store tables of data, basically coming from a SQL database or Excel file, you can also store images or sound files. That works as well. And they are versioned. All that stuff that I upload to this portal is stored in a data store. And a data store is a Azure blob storage that's being used. So I can show you. Let me go to my resource group, storage account, containers, and there's my storage, customer churn raw. Hey, my CSV file is there, and also an additional file, but let's ignore that for a minute. So it's all stored in blob storage, which is scalable, fast, cheap to store, so that's good. So how do I get data in here, actually? How do I clean up my data set and get started? So typically what I do is I use this task, make dataset, to upload datasets to my Azure environment. So the way this works is like this. When I want to get started with Azure Machine Learning Service in Python and I want to upload datasets to my environment, I have to do one thing, and that is go up to my workspace over here and download the configuration file. This config file contains information about the subscription that I'm using, the workspace that I'm using, and the tenant ID. So it's a bunch of GUIDs basically. It points my Python Azure Machine Learning SDK towards this workspace. So how do I use this config file? It's here. I'm not going to show you that because it's a lot of GUIDs. It's not really interesting. Inside my Python code, I can grab the workspace class from my Azure ML core package and ask for an instance of it based on the configuration file that I have. That's a good question, Edwin. Is it always stored in Azure Storage? Let's find out. New data store. So, no, it doesn't have to be. So, you could use an Azure Data Lake if you have that. You could use a data warehouse if you have that. Postgres is also supported. MySQL is also supported. Keep in mind though that Azure Blob Storage is the most flexible one, and SQL will obviously only store tables and nothing else. And in fact, you can only read from those SQL stores, so that's kind of. But you can use them. Typically, what I do with customers is that sometimes if I have a raw data store, an operational data store that I want to read data from into a data set, I will add it here. I will add it as a data store, and I read from that and create a data set using Python code. That's actually the way to go. Yeah, so you can do that. Cool, so in my Python code, I will grab the workspace, and from this workspace, I will grab the default data store. So going back here, this is the default, so this is my blob storage. Then what I do is I will grab a folder on my disk, this one, the raw folder, and store it in a folder inside this data store. That's the first step that you have to do to create a data set. These are a couple of settings. Typically what I do is say, well, overwrite the heck out of it, I don't care, because I will make sure that this is a different folder each time I upload. In the default template I don't care about it, but for the most part this works. Then what I do is I will try to look up an existing dataset based on a name that you've provided as input. And if it doesn't exist, I will create a new dataset. So this line, dataset, a tabular dataset even, created from a set of delimited files based on this data store that I've got here, and the output folder that I uploaded my files to. And then what I do is say, well, register this dataset in my workspace, give it my name, and if it's not a new dataset but actually version 2, create a new version. So in this case, I've got a dataset, customer churn raw, which is version 1. Let's upload a new dataset. So Python tasks make dataset dash help. So what I've done, I've actually created command line utilities for this. This makes it a lot easier for me to actually work with them. Name, customer, churn, raw, input folder, data, raw, customer, churn, output folder, customer, churn, raw, 2. Oh, I have to specify a directory rather than a single file. So it can upload multiple files in one go. As you can see here, it's doing that. So now it has uploaded the files for me, and it registered the dataset. So now when I go here, I've got version 2. So this is how versioning works actually. So how do I use this then to actually train a model? Well, that's pretty cool. I can say consume, copy paste all this stuff into my Python code and load my dataset back from the portal. That just works. However, this is kind of evil to do. Don't do this. Because why? It's in a config file. I don't see why Microsoft would do this actually. It's much better to actually say workspace from config and then work from that. But whatever. One of the other cool things that I'd like to show you actually is, so I've got a version 1. And let's explore that dataset. Let's see what it looks like. So what you can do in the portal is actually look at a sample from the dataset and it will tell you, hey, this is a string and this is a boolean. It knows what it looks like. So you can explore your dataset. It does even more cool stuff in here. It can also profile your dataset and tell you what's the balance between male and female like, or what's the distribution of your data across tenure. What does the monthly charges look like? And this is important information because this is my reality check. So if I've got a data set that poorly represents reality, so it's all customers that are really loyal, but in reality you've got 80% of your customers that are leaving within 2 months, then that's bad for the machine learning model. The machine learning model will try to learn rules from the data it sees, and all the data that it doesn't see, it is unable to process into working stuff. So if you've got all high-paying customers that are staying with you for years, but in reality that's not true, your model is going to be off by a mile. So this is important to have this profile. From this I can ask the customer service, is this a normal that most of the people are actually not paying that much for the subscription? If that's the case, then that's fine. If it's not the case, we have to fix the data. Okay, so having said that, let's move on to the next step. The next step is to actually train a model. So training a model is actually done using experiments. So let's go to the portal first. In machine learning, we talk about experiments because we are trying out stuff. There's another question before I continue. So you mentioned before data quality. Can you elaborate a bit on some basic checks you do on data before you do all the steps, making it visible in a model? So one critical step that I always do is check for nil values. Missing data is one of the key breaking points for a machine learning model because the algorithm can't train on missing data. It throws an exception, that's basically it. Then the other thing that I always like to do is check for imbalances in the dataset. So if, in this case, if I want to predict a category, yes or no, someone is leaving or not, I want an equal set of people, ideally, an equal set of cases that say yes, and another set that says no, and they have to be in balance. On the other hand, what I also want to make sure is that it represents reality. So I have to ask the customer, does it fit your general sense of reality. Sometimes they don't know, but most of the time they know. Another good quality check is are values encoded correctly. So if I have a yes/no column, do I have yes/no in there? And not yes/no garbage, hello world, etc., etc. So that's basically the check for what I do. Another good question is, and are you fully responsible for manually finding and removing biases in your dataset, or are there any tools for this? So one tool, this is what I just shown, the profiling stuff. So this is only to show me that there is a problem. There's no solution to fix this actually, sadly. That's why it takes 80% of the time. There are, however, great tools to point you in the right direction, and Pandas is really easy to use in that case. But it takes time. Sorry. Yeah. So going back to the experiments. So machine learning is actually a lot about experimenting and not so much about coding as in normal software engineering. Although I have to say that having worked on a number of projects, quite a lot actually, we are still experimenting a lot everywhere. But machine learning is more extreme in that sense. So experiments in machine learning allow you to track a number of things. So they allow you to track which code was used to train the model, and the git hash, the commit hash for the version of the code that you use. But you can also log all sorts of metrics in a experiment to help you keep track of things like, how well is my model doing? How long does it take to train the model? How many records did I use for testing versus training? That sort of stuff. That's all important for me, because then I know whether the model that I created is actually usable in the end, aside from data quality. But let me show you how that works. So let's stick this in a separate file for now and do something fun. So like that. So go away. Workspace experiment. So what I'm going to do now is actually locally run an experiment on my machine. I've got a let me quickly check what I've got over here in terms of performance. So I've got a bunch of cores. And there's a lot of them. A big pile of memory, and if it's super fast, 1 terabyte SSD. So should be possible to do this. So let's say workspace from configuration. Then experiment is experiment workspace customer churn. So what I'm doing is I'm loading a workspace and creating an experiment called customer churn, which is located in my workspace. By the way, for those interested, I've got IntelliSense right here, which is pretty cool. Then what I can do is, with experiment.start logging as run, I can start a new run actually here. And in this run, I can say log accuracy. I can log all sorts of stuff in my experiment. I can also upload files related to my experiment. So if I've got a model trained, I can store it in the workspace in the cloud. I can also register a model when I'm done. So let's train a model. From sklearn model selection import train test split. sklearn dot tree import decision tree classifier. What I'm actually going to do is use a decision tree classifier to predict customer churn. I don't know if this is the best model for the case that I'm working on. Basically what a decision tree looks like is this. It starts with a root and you drop in all the data. And then I will decide based on some value how to split that data into cases yes and no. And the key here is that my computer is going to figure out the ideal splits in the datasets until we've got clean groups of people saying yes and people saying no. And I might be in multiple places in my tree, so I might get a very large tree. That's the idea here. Not to worry about, because my computer can handle that. So what I'm going to do is say classifier is decision tree classifier. Let's also grab the dataset. So ds is dataset get by name. I think it was. Oh, I don't have to class the dataset important. Oh. Dataset. Yeah, workspace, customer, churn. No, I don't need to specify the version. So this is how you get the dataset ultimately into your workspace. It's a one-liner. It's pretty easy to do this. This, however, is just a pointer to the dataset. I'm not downloading it to my machine right now. That's what's going to happen when I do this. ds.to pandas data frame pf customer. Sure. So this will convert my dataset into a pandas data frame, just as I had before. This will download all the data to my machine, which is pretty fast at the moment. I've got a big internet connection, but yeah, imagine doing that with a terabyte of data. So then what I can do is I can say, well, I'm going to train this classifier, but before I can do that, I have to split my dataset in a set of input features on the one hand, and then the stuff that I want to predict on the other hand. So what I'm going to do first is say, well, I know that my output is df customer churn. Churn. So then the input is df customer churn, a bunch of columns. So let's see. I could actually let's keep it simple for now. I know that the columns are in here at the top. So I'm not so much interested in customer churn, in the customer ID, because that's not usable. So what I could do like this. And let's make this a little bit more readable for now. Well, you get the idea. Normally I include all the columns. And in this, what I have now is my input features assigned to X, and I'm using an uppercase letter. For this you need a mechanical keyboard. Yes. Of course you need a mechanical keyboard in your life. Why wouldn't I have one? It's the best. I actually built a custom one last year. A split keyboard. That's... yeah, for the Tommy gun sound, yeah. Among that and for just, yeah, it's cool. I don't know why. So I'm using uppercase X because it's a multi-column vector. And someone is pointing to a Reddit subreddit about mechanical keyboards. Yeah, there's a bunch of people doing that these days. I can highly recommend that. And this is my output. So now that I have my dataset, I have to make sure that my model is not training on the whole dataset. Why? Well, machine learning models tend to remember the samples that they've seen. That causes them to overfit, basically. So what they will do is, because they are trying to remember the samples that they've seen, they will be very good at predicting that. But other cases that they haven't seen, not so much. But I do want them to be able to detect cases where they haven't seen it before. So what I can do to help my training process and to basically detect any problems in this area is do the following. I can say train test split X and Y. and test size 20%. So x train, x test, I train, I test is the output of this function. Basically what this does, it will take a number of arguments without a name. These are my datasets that I want to split. And a bunch of settings, so I can specify either the training size or the test size in this case. I'm basically telling the computer here to set aside 20% of my data that I'm going to use later to verify that my model was indeed able to distinguish whether someone is going to leave or not based on samples that the model hasn't seen before. Keep in mind though that it doesn't save you actually. So your model is still going to overfit no matter how you put it. But you can detect it at least. And we'll talk about overfitting a little bit later. So now that I've split my dataset, I can say, well, classifier, let's train you, fit, x train, y train, and out comes a model. This will create the algorithm that I'm going to train a model with, and this will output a model. So if someone starts talking to you about it's a machine learning model and then suddenly switches to algorithm, that's wrong. The algorithm is the piece of code that is actually going to, in this case, select how to split the data, how to build the tree that the data is going to flow through. And the result of this function, the result of this algorithm, is the model, the actual tree in my case. So what I can do now is this I can store on disk and start predicting with. But what I wanted to do is actually verify that my model is working. And this I'm going to log accuracy score. And we'll save the model later. So this is my initial training script. So what I can do now is say, let me grab the other terminal for this. So now that I have this script, I can say in my terminal, Python, customer churn, train.py, and it should go up to Azure Machine Learning Service, download my dataset, and then start training my model. So in this case it will take a while. Okay, it's going to give me some value errors. Basically what happens here is that it's not stored as a number, which my machine learning model requires, but it's stored as a string. And I can fix that. So basically what I have to do now is go back to my dataset and basically fix the problems that I have in my data. So let's convert categoricals apply. So let's build a script for that. Import pandas as pd. No. pd.read csv data raw customer churn.csv, and a values is oh, it's formatting it automatically. Annoying. df customer churn, so columns is, and I'm going only with a subset of columns in this case because it takes quite a long time to do this actually. So I'm going to create, grab these. Well, actually, now that I think about it, I can probably use this one and the charges as input. The model won't be as perfect as normal, but let's do that for the sake of time also. So what I can do here is say, I'm not really interested in gender and all that stuff. I'm actually interested in monthly charges and total charges. And let's keep it at that. So I can run this again. And possibly, I am not sure if I've cleaned the dataset properly at the moment, but yeah, it's another number, so but we can quickly fix that. Drop and that could be it as well, Edwin. Yeah, but what I'm seeing here is not a number, which means that the column is actually empty. So what happened here is it's complaining because my environment is slightly strange, but it has trained my model actually based on the columns that I selected. Just to go back to your question, Edwin, so you were saying maybe it's the casing of the columns, but actually it isn't. So it says error, class value error, input contains not a number, infinity or a value too large for D-type float 32. It's sort of off-throwing, to be honest. This one, however, isn't. So the case here is that not a number means that it's indeed empty or a string, so it doesn't understand. I know for a fact that this total charges column was actually empty in some places. I didn't clean up my dataset and upload it in the correct way to my workspace, so I forgot to drop the empty rows. But I can do it just as fast over here. So once I've done that, I've got my dataset, I've split it in two, I've trained my model, and I can score my model, and I can say, which column are we talking about? So there's total charges, which is with a capital, monthly charges. Oh, let's go back. Which is also correct. And then there's tenure, which is funny in this dataset because it's lowercase full. No problem. Happy to help. Thanks for checking, making sure that I've got it correct. Yeah, it's working as well. What you see in this final line is only a warning that it says, well, your pandas version is wrong and weird, but it does work, which is fine. So if I go up to the portal, I've just run my experiment, I can see that there's data actually logged in my experiment. So each experiment has a name and it has a couple of runs. So you can run one experiment multiple times based on, well, me screwing up or something. That's only 5 minutes left. Yeah, that's true. For this guy, it is 5 minutes left. But we'll never get to the deployment part. Oh well. So I've got one run completed, and it has metrics, and there's my accuracy, 71%, which is no rules tonight. Yeah. Indeed, yes. So that's a good point of. That's a good point. So normally we would take an hour to do this, but I haven't prepared anything. This is all live. It's happening behind my computer. I'm screwing up, and that's why it takes longer than an hour to show you. Otherwise, I would have to copy paste. So we'll continue after the official timeline. Exactly. Stay as long as you like. If you feel that you have to go for some reason, please go. I'm recording all this. It will be available online. You can all watch it back, and I will probably edit out some boring stuff, if there's any. So let's continue. So these metrics, these are pretty interesting to me. Why? Because of reproducibility. I know a number of things over here. I don't know the dataset that I've used at the moment, but we'll fix that in a minute. But I do know the output of my script, which is this. So normally when you use datasets properly, and not like I did just now, you will get which dataset and which version you've used. So you know this was the input data, these were the settings, and this was the output. I can actually show you that it captured the code that I used to train the model. So I know what stuff is in there. Actually, I can show you. This is the stuff that we use to train it. So it uploads that to the workspace. Not so. It does point to Git, but it also creates a copy of Git. That's pretty cool, actually. So let's move on, and let's pimp this up a little bit and say, what if I were to use remote training? So let's go back to my original code and say, well, instead of creating a new run, let's use the current run that's running. And instead of loading the dataset myself, let's grab it from what the person that started the build task provided me. So dataset, okay, cool. Let's throw this away. Let's grab this code. Oh. So there's my stuff again. I need this as well, of course, because yeah, otherwise it's not going to fly. And I need this as well, because I need to split my dataset in two pieces, just to make sure that I'm not overfitting. And I can say, well, I've got, and I will go over this in a minute. So let's throw this away and then say whatever. Okay, so basically what this does is says, well, if you're running as part of a run on some environment, and I will show you what that is, please get me the current run. Then grab one of the input datasets that I use for my model and turn that into a pandas data frame, and then drop the empty rows because and then pre-process it like before. So grab the inputs that I use and the output that I want to predict, split it in two, so I've got a training and a test set. Then train the model just like before, log the data that I want, and then I can actually start to upload the model as well. So let's do that too. So people who work in Java or .NET, you've got cool serialization libraries, you think. But Python's got one better. This one actually dumps a whole object on disk. Memory mapped. Sort of weird stuff. So what I can do is actually say joblib dump my model into outputs model.bin. Then run upload file model.bin from outputs directory model.bin. So this will save my model to disk that I trained over here. And this will upload it to the Azure Machine Learning workspace. Then I can say register model customer churn based on the file that I've uploaded, model.bin. So at the end of the run, when I'm ready training, when I'm done training, I can save my model and upload it to the workspace. So how do I run this then? Well, I should show you that Azure Machine Learning Service doesn't only allow you to train on your own computer. It also allows you to train on a separate training environment. So you can have training clusters. That's a good question as well. So is the resulting model from this file that we have over here, is that a proprietary format or is it reusable in other environments? So it's a proprietary format at the moment, actually. It doesn't have to be. There's options. So I'm going to show you, yeah, the answer is ONNX. So ONNX is an open neural network exchange format. This is a interoperable machine learning file format. And it allows you to run models on other machines using ML.NET, Python, if you want to, C#, Java. Actually, what I like to do is grab my model that I trained and export it to Onyx and then run it inside C# or Java, Python is very, very slow in production. I believe that the benchmark for it is around 200,000 requests a second, while .NET Core is at 3 million at the moment, which is such a big difference that, to me, it makes more sense to run a model in production in C# rather than using Python, which sucks, which is... Yeah, so that's another good point. Onyx is integrated in a lot of environments. SQL Server is going to allow you to call predict. And there's more, actually. I can show you. So, it supports a number of frameworks. There is scikit-learn that we're currently using for our case. But there's also Cognitive Toolkit that I wrote a book about. Don't use it anymore. There's also PyTorch, there's TensorFlow, there's a lot of other stuff in there. When you want to deploy a model, you can actually run it on hardware directly. So there's chips that they bake that have Onyx support in microcode. That's a good question. Are you going to write a book again? To be honest, I spoke about it. I spoke to my wife about it, and yes, there might be one. And it's going to be a popular topic. I hope, if my publisher allows me. NVIDIA supported Windows support. So there's a number of stuff that things you can do. Actually, it's pretty cool. So Onyx, yay, it's a good idea. So let's run this. So we have a training environment in Azure Machine Learning Studio that is right now a standard T3 v2. This is a standard virtual machine, not too big, not too small, but I can have more, so that's pretty cool. While that loads, so this is what happens a lot of the times. So I'll leave the details out here because it's not working. Actually, if you want to set up an environment, in my template it's included. You can create a new training cluster quite easily using a build task. It's just there for ease of use. So I can show you that these are the machines, but you can also use GPUs, 12 core GPU, two graphics cards included. This is very expensive, but you can do that. So it's pretty cool. Let's run our script against a remote environment. So what I can do is Python tasks train model, which is my build task that I use for training my models. And this is the one that's going to help me train my model. Let's take a look. So it does the same stuff. It's a command line utility. It has the workspace and the experiment and a compute target that I can specify. And what it will do is it will start a new experiment based on scikit-learn remotely on this compute target, and it will feed the dataset that I select, that I specify the name for, into that experiment, which is pretty cool. And then it will submit this new training script to the experiment, actually, to train the model. And then we'll wait for it to complete. So let's do this. Experiment is customer churn, environment is CL train, dataset is customer churn, far away Bob. And what you can see here is when it starts running, so yeah, there we go. So here's my fourth run. And what you can see here actually is that I'm now using a compute target, a virtual machine, to train my model. So I'm no longer using my computer. I can actually turn it off. But we would go offline on the stream, but I can turn it off. So if I've got a deep learning model that's running for more than 24 hours, which happens in practice, then I can just leave it running in the cloud. It also specifies the script that I've used. And it also specifies which dataset I'm using. So I can click here and it will show you, hey, this is a dataset. One file, one version. So now I've got a fully traceable experiment outputting using a dataset version, training a model, outputting the model into my workspace, but also tracking the metrics. So now I've got a fully reproducible environment that I can be sure about. It also tells me, see this, all my Git workflow stuff, so it knows. Now, this will take a while, sadly. So it's preparing at the moment, so I can show you around a little bit of what's happening in the background. So everything that's done is done inside a Docker image. So we'll schedule a Docker image on this virtual machine. And you can specify what should be in this Docker image, actually, in terms of Python stuff, through this environment file that I showed at the beginning of my session, at the beginning of the evening. So it's in there. And it will install a lot of stuff, and it will do things. It will take a long time. And we'll have to wait because I don't have a backup version. At least I don't think so. We could try and see. No. Do I have one? Maybe. Maybe. It's actually one from Joop, but I'm not sure if Joop is using. No, he's using automated machine learning, so it doesn't help us. Sorry. We'll have to wait a little bit. It's preparing, so that's good. Okay, let's leave that running for a little bit. So this is not too hard if you're used to machine learning. Let's be honest. If you're completely new to machine learning, then this is actually aimed at experts. I would say. So, speaking of which, the other thing that might be more interesting to you if you're not into this whole Python thing and you think, I'm not a machine learning expert, but I still want to build a model. There's this. What I can do is say, well, I've got my customer churn dataset. Please give me a name. Customer churn automated. Target column, churn. Select the training cluster. Next. No, I don't want deep learning. I want classification. Thank you. And that's it. So I've got the same stuff that I wrote in Python now in a visual interface, and I don't have to think about what type of model I have to use, what kind of parameters I want to use, what random numbers I'm inserting, all that stuff. And it still trains a model. So Azure Machine Learning Service not only helps you as an expert in setting up your machine learning project properly, but it also helps people who might not be as good at programming as you work on machine learning. As long as they understand that a machine learning model is based on chance, on probabilities, and they are aware of the fact that it might get it wrong, this is a perfect solution actually. It's still being tracked, so the experts can actually use that. Thanks, Edwin. See you later. Thanks for the questions. So yeah, this provides a great solution for people who don't know anything about machine learning as well as experts. And if you're somebody in between, you can actually use a graphical designer. So I'm not writing code still, but I do know everything about machine learning, but I'm uncomfortable with Python. Well, sure, no problem. You can do that. You can say, well, I want a, let's see, where is it? A two-class decision forest. I can say, well, let's see, model training, train model, I know that I have to do this, I have to do this, and I can say edit column. Churn is the one that I want to predict. Save. Yeah. Use other compute target. I can select my cluster. And yeah. Sorry. This is the graphical way of building the same thing that I just did. So that's the cool thing about machine learning service, I think. Microsoft targets both experts that know what they're doing and want to write code. They also target people that, well, I have this dataset, but I don't know anything, and I want to do some cool stuff with that, but I don't know what models to use and all that stuff. Yeah, you can do that. Everyone can do that. And I encourage you to do that, but at least do it this way. So if you have a problem, you can ask an expert to help out if needed. So the downside to that's a good question. So what are the downsides to using a graphical user interface? The level of customization is lower than what you could do in Python code. But other than that, there's no downside, I think. I personally use a lot of Python code because I like to write code, but I can imagine if I'm in a pinch and I have to hurry up, that this might also help me. So, what's cool? Yeah, that's a good comment, Manon, of Douwe, actually. So, you don't want people who have no idea what they're doing to think they are doing proper machine learning. What is proper machine learning in this case? Is my question then. I personally feel that if you have a basic level of education in machine learning and you are aware of the probability-based approach, and you know that you have to make sure that the data that you use for training represents reality and is not garbage in the sense that it contains all weird values, then that's proper machine learning, actually. Let's be honest, I spent years doing this. I actually started working on a knowledge management system, 9 years ago. And back then I didn't know what machine learning was. But the feeling that I have is that machine learning engineers and data scientists are just experimenting away. They're just trying to do their best, but they don't know either. And in most cases they know how the algorithms work, but the funny thing about machine learning is you can sort of do an educated guess of what is actually going on, but as soon as the random number changes, it's different and you don't know. It's a statistical approach. There's lies, there's damn lies, and there's statistics. And this is based on statistics. Yeah, so that's a good comment also. There's a certain limit. Yes, there is. Splitting a dataset. Have you seen me split the dataset at all for the automated machine learning? I haven't. And I don't need to, because the computer takes care of that. Is it really something that you want to think about as a person building a machine learning model? I don't think so. It's tedious to do so. You see me fumble with columns, and you see me fumble with empty values, and you see me throw away a lot of stuff. That all lowers the productivity bar. That's the problem. So, in the meantime, my experiment run is finalizing. It's completed. It has registered my model, customer churn, which I can also observe over here. Here's my model, which is uploaded to the workspace. And it's registered over here, actually. I've got a customer churn model. Hooray, hooray. It's working. I can see that this model is produced by this run. That's the other thing. This is all reproducibility, all making it traceable for people. if you have to build this sort of stuff yourself, that's kind of hard to do. So you were referring to the designer flow, going back to the discussion that we have about a certain limit. Yeah, you're right. In the designer, you have to think about splitting the data yourself. But I don't think a lot of people use the designer if they don't know that they should split the dataset, because they don't know what model to use. So for those kind of people, there's the automated machine learning stuff. But still a good comment, I think. Yeah. So this model is now registered, and we can start looking at deployment. And I can do that through Python again. So I can call deploy model over here. And what actually happens is I've got a couple of options to deploy my model. So I can use Azure Machine Learning Service deploy model. So there's a couple of options for deploying models. Thanks, Marco, for joining. Intruder. Yeah, there's an intruder. Yeah, that's my wife. She's bringing up another chair. We've got a home office situation at the moment. We've got 3 desk chairs and we have to switch them. So going back to my models, I can deploy models in several ways. So you can do it manually from your computer. I wouldn't do that. But you could also say, I am going to use Azure Machine Learning Service to deploy it. And so let me see. There's actually Azure Kubernetes Service that you can deploy to. You can also deploy to Azure Container Services, container instances, IoT Edge. So you can use your model inside a Raspberry Pi if you want to. An FPGA or a GPU or an app service or functions. There's a couple of options. For me, Azure Kubernetes Service sounds awesome, but it's also really heavy. I wouldn't use that as a first option. Instead, I would go for Azure Container Instances if you are deploying a model for small-time use. Azure Container Instances can be scaled. Not as good as Kubernetes, but they can be scaled. And they're pretty cheap. If you're running in the field, IoT Edge is of course the best option there. This one, Azure Functions, is new. And I like to point this out because Azure Functions is a consumption-based way of deploying stuff in the cloud. And so if you're only calling your model once or twice a week, this is a lot cheaper actually than running a container in the cloud. That's for sure. So these are the options. And in Python to deploy, you can say, well, I'm using an Azure Container Instance web service type of deployment, and I can create a new deployment configuration. I can specify what my deployment of my model should look like. I want 1 core, 1 gigabyte of memory, and I want application insights. Then what I can do is say, well, I need some way of scoring the input of the customer that's being sent. This is my scoring script that I have, and this is the source directory that I want to read this file from. So this is my scoring script. In here, I can actually say, grab the data from the incoming HTTP request that's being sent to my model, turn it into an array of numbers, and call predict on the model. That's it, basically. And this scoring script actually gets the model injected automatically by the Azure Machine Learning Service. It's packaged in the Docker container for you. And basically what happens when it starts, it will call the init method, in which you can use joblib to load your model, and then run is called every time a request is fired towards your container instance. So then when I have these pieces of configuration, how to actually predict and how to deploy, then I can say model.deploy Here's my workspace. This is the name of my web service that I want to create. These are the models that I'm using. You can use more than one, by the way. And this is how to deploy and how to score. So I can do this. I can say Python tasks, deploy model. Let's see what I need to insert in there. So dash name, customer churn, model, customer churn. This one is the model that I actually stored in my Azure Machine Learning environment. So that's this one, customer churn. So this will fire up my deployment script. Oh, I'm not allowed to use underscores in the service name. Excuse me. Sure. It's deploying. What you will end up with is a endpoint that you can call. And there's a difference between different endpoints. So the way I'm deploying the model right now, it's a Docker container that's a real-time prediction. I send a request and I get back a prediction. That's how this works. But you could also do batch-driven prediction. And these are the pipeline endpoints. So if you're running a batch process inside your company and you have a large amount of data that you want predictions for, don't use the real-time prediction. It's very expensive and very slow. The batch prediction is a lot better. Basically what happens is all the data that is used for prediction is sent to this one compute instance that you're using, and then all the predictions are made, and the result is it piped back to the original data store that it came from. That's pretty cool how that works. I don't see it loading right here. It's running at least, so that's good. That's a good thing. So here's my endpoint actually being created. This is a pretty slow process because it has to build Docker containers and all that stuff. But just to show you how that works, at the moment it's transitioning, but it's a Azure container instance. It has an ID and all that stuff. And I can say consume, and I get a REST endpoint back. So I can use C#, Java, Python, Ruby, PHP, whatever you're running to make a prediction. So just a summary. So we started out with a data set at the beginning in here, versioned correctly. Then we created an experiment in which we trained our model and making sure that it's not on our own machine, but on a dedicated environment, and with all the tracking that comes with it. So all the metrics that I want in a model registry, so I can trace back what I've been doing. Then we've looked at models, how to version them, and finally we've looked at deployment to production. Thanks for joining me. So yeah, that's basically it for the most part for Azure Machine Learning Service. There's a couple of other things that might be interesting to you. So I've shown the designer and the automated machine learning for non-expert machine learning engineers, I would say. Another cool thing is that once you have a model, you can actually get an explainer in there. The other problem that we have in machine learning is that a model is sort of a black box. You don't know what's in there. But you might want to know what's in there because your customer is required by law to be able to explain why a certain decision was made. Well, explainers help you to do that. And there's a great how-to guide included that helps you set that up. So yeah, if you have a model and you train an explainer alongside that, you have an explainable model, and that's a lot better than having a black box, basically. The other thing that's also interesting, so if you're building a image classification project, you're typically working with a lot of data that you have to label. And data labeling helps you specifically in labeling images or object detection, that sort of stuff. Sadly, NLP-based tasks are not supported at the moment, but I guess they will add that in the future. I'm not sure. So that's it, basically, for Azure Machine Learning Service. I hope you liked it, this experiment. Please let me know in the comments if you have any other questions or comments that you'd like to add. I'll stick around for a few minutes, or a few more minutes, maybe 10. And with that, I'd like to thank you for your time, and hopefully see you soon. Thanks, Olaf, for your comment. Yeah. I sure hope so. Yeah, that other people will do this as well. Yeah. And be sure to tune in on April 8th. We have a live stream of 30 hours. live.globalai.community. So this is our live stream event that I'm setting up with Henk Boelman. Yeah, thanks. Cool, cool, cool. Oh, by the way, I think we have a... Do we have the automated machine learning? Yeah. Oh, it's still running. Whatever. Will you be streaming for 30 hours straight? Yes. We have an advanced setup for that. We're going to, so I'm going to stream for 15 hours and Henk will also stream for 15 hours. So I will be sleeping in between. I will. Yeah. We've got 30 speakers from across the world also. So there's a lot of people involved in this. And we're all doing this from home. Yeah, I see the problem now. Yeah, it's constantly throwing things off. So if I sit in front of that, I'll sit like this for now. Cool, thanks, Olaf. Hopefully a lot more people will watch. Yeah, it's kind of strange. My camera is constantly shifting. It wasn't doing that yesterday and this morning. I guess something's up with the settings. I changed something, probably. I can fix the lighting, I think, but I'm not sure. Oh, that's really bad. This better. Actually, yeah. So I fixed the settings. It was a problem. It removed the settings that I had. Cool, cool, cool. Awesome, people. Well, thanks. If there's any more questions, feel free to comment on Twitter. And with that, I would like to thank you for today and see you soon.